Okay, Honors Math 3. In Unit 1, we start to explore some things about different bases. Now, you're already familiar with base 10. Why is base 10 called base 10? Because we have 10 single-digit representations to represent numbers. So those would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now that's 10 digits though, single digit representations representing things. As soon as I go beyond 9, it requires 2 digits to do the next number. So the next one, obviously, is 10, but it's written 1, 0, and then 1, 1, 1, 2, 1, 3, and so on. Okay, now what if, and by the way, notice this is base 10. To actually write a 10, it takes 2 digits. What if we were to do something maybe in base 5? Okay, so base 5 is 0, 1, 2, 3, 4, and then as soon as we get to what we actually want to write as a 5, it will require 2 digits to be able to write it. Okay, and so writing it, it is a 1, 0. That is 5 in base 5. Because in base 5, you can't have anything bigger than a 4 that is a single digit representation. So there's 5, 6, 7, 8, 9, 10, 11, 12, and so on. Okay? So single digit representations, it's always one less than what the actual base is. So again, if we were actually to be doing base 3, that means we've got 0, 1, 2 before we start using 2 digits. Here's a 3, 4, 5, 6, 7, 8, 9, 10, and so on. Base 3. What if we have a base that is more than has more single digit representations than base 10? Perhaps you've heard of hexadecimal. This is base 16. If you saw the movie The Martian, they were using hexadecimal. Okay, so base 16. So here goes. We have to have 16 single-digit representations to represent 0 through 15, in other words. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I want a 10, but it has to be a single-digit representation. Now, just to follow what the rest of the world does, There's 10. 11, 12, 13, 14, 15. And once we get 0 through 15, now to get base 16, once we get there, now there's 16. I did the wrong color there, didn't I? $16, $17, etc. I just went off the edge of my page, etc. Okay, so starting to get the idea just a little bit. What's my biggest digit representation here? 7. So you know that this has got to be at least base 8, and that's what I'm going to do with this one. This one's base 8, and we want to convert to base 10. Okay, so there's probably some other ways to do it, but this is the way that I think makes the most sense, because really, I mean, it's like we're doing it because this is what is really happening. When you have a number 4731 base 8, let's take a look what it means when we're doing base 10 before I even do that number. If I have 1974, why does that represent 1974? It represents it because we have this is the 10 to the 0 spot, this is the 10 to the first column, this is the 10 to the second column, this is the 10 to the third column, otherwise known as the ones, the tens, the hundreds, and the thousands. And so 1974 is 1 times 10 to the third plus 9 times 10 to the second plus 7 times 10 to the first plus 4 times 10 to the 0. Well, 1 times 1,000 plus 9 times 100 plus 7 times 10 plus 4 times 1. So 1,000 plus 900 plus 70 plus 4, which is 1,974. Okay, and that's why it is that number. Okay, now we're going to convert these numbers in something besides base 10 to base 10 based off the meaning of the number itself. So this column right here is the 8 to the 0 column. This column right here is the 8 to the first column. This column right here is 8 to the second column. This column right here is the 8 to the third column, because we're in base 8. Okay, so now I usually start at the right-hand side and work my way to the left, but you could start on the left-hand side and work your way to the right. So I have 1 times 8 to the 0 plus 3 times 8 to the first plus 7 times 8 to the second plus 4 times 8 to the third. So I have 1 times 1 plus 3 times 8 plus 7 times 64 plus 4 times 8 to the third is 512. Now, little calculator's probably a little bit handy, but I have 1 plus 24 plus 7 times 64, 448 plus 4 times 512, 2048, which is 2,521. This is base 10. Because we converted it into base 10 that way. Okay, let's try another one. Let's do one where the base is bigger than 10. Let's do well, let's just go ahead and let's do base 12. So now, anything that's bigger than base 10, you're going to use A as the single digit representation for the 10. The B is going to be the 11, and so on until you get as high as you need to. Okay, so realize that A is 10 in base 10, and B is 11. So we want to keep that in mind. Okay, so A, this is in the 12 to the 0 spot. This is the 12 to the first spot, 12 to the second spot, 12 to the third spot. You don't have to keep on writing those in if you don't want to, but if it helps, at least at the beginning, you can go ahead and do that. So, A times 12 to the 0 plus 0 times 12 to the first plus B times 12 to the second plus 7 times 12 to the third. Okay, now what is A really? A is 10. And 12 to the 0 is 1. Plus, okay, 0 times, that's just 0. What is B really? B is 11. Times, and what's 12 squared? Well, it's 144. And 7 times 12 to the third? Okay, well, it's 7 times, and 12 to the third is 1728. Okay, so we've got 10 plus 0, you don't have to write the plus 0, plus 11 times 144. Like I said, a little calculator is helpful. Plus 7 times 1728. Okay, so $13,690, and that is base 10. Okay, now something that you will notice when you have a number that's a base bigger than 10, then probably it will be more digits long when you put it into base 10. On the other hand, if you have something that's in a base smaller than base 10, then it's going to be the same number of digits, or it might actually even be shorter, lesser digits than what the original number was. So, for example, here this 4,731 base 8. It's not really 4. It's 4731 base 8. But notice how it actually looks like it's a smaller number here in base 10. They're equal numbers. It's just they're in different bases. Whereas the 7B0A is actually even one more digit long in base 10. Okay, so that's how we convert to base 10. And you really only have 4 problems that you're going to convert to base 10. Here is the assignment. Bases number 1.1. Convert to base 10. Okay, so problem number 1. 1, 0, 0, 1, 0, 1. This is base 2. Convert it to base 10. Number 2. 3, 2, 4, 1. Base 5. Convert that to base 10. Number 3, 7, 0, 5, 1. Base 8. Convert that to base 10. And number 4, A, 7, B, 3, base 12. Convert that to base 10, and I'm going to give you one more. Let's have you go ahead and do a hexadecimal here. Let's do 8D 3E. Base 10. Okay, so really just 5 problems. That's the assignment. Do a good job with it. You need to show the work.